Alright, so we've got these functions lambda I, and we want to find formulas for them. So again, we've got this triangular domain that we're looking at, and we've got a1, a2, a3. These aren't exponents, these are just indices. And the reason we're using that is because this is in 2 dimensions, so we need a1, a2. So the subscripts down here, this 1 and this 2, that's the x and y coordinate of this vertex of the triangle. And the exponent here, or the superscripts rather, those tell you which vertex you're looking at. The first vertex, second, or third. So these lambda i's, yeah, we know lambda I should be 1 at lambda I should be 1 at the vertex AI and 0 at the other 2 vertices, and they should also be linear. And let's see here. So what do we know about these lambda i's? We know that, let's see here, that if the, let's see, what am I doing? The linear function, that if vi is what vai, if we take this point v of ai and call it vi, then v can be written as v of x1 and x2, because again this is a function on the plane, the xy plane, or the x1 x2 plane, however you want to think of it. So it's linear, so it's going to be, you have a constant term, you have an x1 term, you've got an x2 term, where C0, C1, C2 satisfy. Let's see here. So we've got this matrix 1, 1, 1, A1, 1, A1, 2, A1, 3, A2, 1, A2, 2, A2, 3. So you've got a 1, and then in the first column you have a 1. In the second column you have the xi coordinate. In the third column you have the xj coordinate, or the x2. In the second column you have the x1 coordinate. In the third column you have the x2 coordinate, and then each row, these will correspond to a particular vertex. So if you take this matrix and you multiply it by C0, C1, C2, then you'll get V1, V2, V3. And in fact, this is a non-trivial fact, but it is true that if A1, A2, and A3, these vertices, if they do not all lie on the same line, then this matrix will have a unique solution. And that's you have to prove that, but that's one of the other exercises, so I'll just leave that to be done at some point if you want. So we want to use this to find the formulas for v. We want to write these lambda i's in these forms, the C0, C1, C2. So we want to take for each lambda I, we want to find the corresponding C0, C1, C2 values. So now note that, so if A equals A, B, C, D, E, F, G, H, I, so A is a 3x3 matrix of just variables, then A inverse is, let's see, you take 1 over the determinant of A, then you multiply by, alright, EI minus FH, FG minus DI, DH minus EG. So that's the first column. Second column, CH minus BI, AI minus CG, and BG minus AH. Third column, BF minus CE, CD minus AF, and AE minus BD. So this is just a linear algebra fact, and where are these numbers coming from? Well, if you look at this, well, this is the 1, 1 entry of this matrix. And if you go back to A and you delete the first column and first row, then EI minus FH is just the determinant of the remaining matrix there. And that's not just a coincidence, that's how you define this matrix. So if you go, let's say you go second row, third column, and you delete the second row and you delete the third column, and you take the determinant of the remaining 2 by 2 matrix, you get something that is not what I have written down. Okay, so what did I mess up here? Oh, it's flipped. It must be flipped. CD. Okay, yeah. So I flipped this. It should be down here. This is in the second row, so you delete the second column, and this is in the third column, so you delete the third row, which is confusing. But wait, does this even work? Yes, it does. Because what you have to do is, after doing that, you have to put like minuses on these 4 things. Okay, this is sort of going off the rails. Just look up linear algebra if you want to know how to get this. Just look up facts about 3 by 3 matrices. You'll find something. So then what can we do with this? If we let A equal, check this out, copy, paste. Oh, that's the best. It's really nice having a tablet for things like this because you don't have to rewrite really complicated formulas. Then A inverse is given by, so we got 1 over the determinant of A, and then what else do we have? We get EI minus FH. Now this is just F minus I. Wait a minute, what am I doing? No, let's go ahead and plug in the actual values here. And this is just something that you plug in the different values and you'll get this. You can just sort of trust me on this. Or do it yourself if you don't trust me. A22, A13, A22 minus A23, A13 minus A12. Okay, so that's the first column. Second column, A21, A13 minus A11, A23, got A23 minus A21, got A11 minus A13. Then last column, we get, let's see here, A11, A22 minus A21, A12, get A21 minus A22, A12 minus A11. Alright, cool. So, for lambda 1, we have V1, V2, V3 equal, well, we want lambda 1 to be 1 at the first vertex and 0 at the other. So it's going to be this. So we have C0, C1, C2. This is going to equal, well look, C0, C1, C2, this was here. Let's call this will be called the vector capital C, and this will be called the vector capital V. So V is 1, 0, 0. So C is going to be, well, if A times C equals V, then C must be A inverse times V. And A inverse is given by this formula up here. And let's see here. We could do this ourselves, but if only there was an easier... Well, no, we don't need to do that. It's A inverse, so I'll just keep that 1 over determinant A. I'll just write absolute value of A to refer to the determinant of A. You'll see that in linear algebra stuff sometimes. And then, what will the vector become? Well, when you multiply A inverse times V, you're going to pick up this column here. So it's going to be this times A12, A23, minus A22, A13, A22 minus A23, A13 minus A12. And thus, the equation is lambda 1 of x1, x2 is going to be, well, we just plug in the different values of C0, C1, C2. C0 is this, and C1 is the second, C2 is the third. So we get A12. Well, here, I'll put 1 over absolute value of A, because there's a 1 over absolute value of A outside of every coefficient, so I'll just pull that outside. Then we'll get A12, A23 minus A22, A13, and now we're going to add x1, and the corresponding coefficient is A22 minus A23, plus x2, and then we multiply by A13 minus A12, put parentheses. Alright, so that's that. For lambda 2, V is 0, 1, 0, so C equals A inverse V, which in this case is 1 over determinant of A, and we'll multiply, we pick up the second column then. So this is A21, A13, minus A11, A23, get A23 minus A21, then we get A11 minus A13. So lambda 2 of x1, x2 is, again, 1 over absolute value of A. Then we're going to multiply by A21, A13 minus A11, A23. Now we're going to add x1 times A23 minus A21. Then we're going to add x2 times A11 minus A13. Okay? Now finally, for lambda 3, V is going to be 0, 0, 1. So C equals A inverse V, blah, blah, blah. This time we pick up the third column. And so that will be, got A11, A22 minus A21, A12. A21 minus A22. Yeah. Then A12 minus A11. Alright. So then we get, let's see here, what do we get? We get lambda 3, x1, x2. It's 1 over determinant of A times A11, A22 minus A21, A12. Now we add x1, and the coefficient is A21 minus A22. then x2 will have coefficient a12 minus a11. Alright, so we found lambda 1 and lambda 2 and lambda 3, and that's what we wanted to find, and so we are now done with the exercise.